Good day and welcome to Kuwader Knows. For today's video, we are going to continue our previous discussion about measurements, the non-standard way of measuring and the standard system of measures. Part 2. If you are new in our channel, please do subscribe and hit the notification icon so you won't miss our future upload. We're going to discuss now the metric system of measurements. The widely used standard system of measurement is the metric system. It is based on decimals just like our numeration and monetary systems. Since its introduction in 1970 by a Frenchman named Gabriel Moton, the metric system has proven to be convenient and ideal to use. Since the system is based on multiples of 10, counting and performing mathematical operations are easier. It is no surprise that the metric system is used in most countries all over the world, including the Philippines. The metric system uses Greek and Latin prefixes to make a conversion from one unit to another in easier way. A prefix is a power of 10 exponent or multiplier that precedes the unit. To illustrate what is meant by a prefix, let us take the standard unit for mass in the metric system, the kilogram. In the terms kilogram and milligram, kilo and milli are the prefixes, while gram is the unit. The table in the next slide shows the Greek and Latin prefixes that are most frequently used in the metric system. And here's the Greek and Latin prefixes. We have the title or the header, origin, prefixes, pronunciation, symbol, and equivalence. Under origin, we have the Greek and the prefixes of tera, giga, mega, kilo, hecto, and deca. Let's start first with tera. Tera is pronounced as tera with a symbol of capital letter T, an equivalence of 10 raised to the 12th power or equal to 1 trillion. Am I correct? 1, 2, 3, 6, 9, 12. Okay, 1 trillion. Next, we have the giga. The pronunciation is giga or giga. Yan. And the symbol of capital letter G for giga. The equivalence is equal to 10 raised to the 9th power or 1 million. Now we have the mega. Its pronunciation is mega or mega with a capital M as its symbol and its equivalence of 10 raised to 6 power or equal to 1 million. In giga, we have the 1 billion pala na equivalence to 10 raised to the 9. I'm sorry, I'm wrong. So giga, 1 billion, and mega, we have a 1 million. Now we have the kilo. Pronunciation is kilo or kilo with a symbol of small letter K, an equivalence of 10 raised to the 3rd power or 1000. Now we have the hecto with the pronunciation of hecto, symbol of small letter H with equivalence of 10 raised to the 2nd power or 100. Now we have the last of under Greek. We have the deca. Pronunciation deca with a symbol of DA. Small letter DA with equivalence of 10 raised to the 1st power or 10. Now let's proceed with the other one. We have the Latin. The Latin have the prefixes of deci, centi, milli, micro, nano, and pico. Now let's start with deci. It's pronounced as deci and have a symbol of small letter D. Now the difference is now its equivalence other than the Greek. The deci is equivalent of 10 raised to the negative 1 or equivalent to 0.1. Now we have the centi. It's pronounced as centi with the symbol of small letter C. Its equivalence is 10 raised to the negative 2 or equivalent to 0.01. Now we have the milli, pronounced as milli, double E. and it have a symbol of small letter m. The equivalence is equal to 10 raised to the negative 3 or equivalent to 0.001. Now, we have the fourth one, the micro. The pronunciation is micro. Yun. The pronunciation is micro. With a symbol of Greek U, and it have a equivalence of 10 raised to negative 6 or equivalent to 0.000001. Now, we have the fifth one, the nano, or it's pronounced as nano, with a symbol of small letter n, and in its equivalence of 10 raised to negative 9 or equal to 0.000000001. So, yung pagitan ay ilan? 1, 2, 3, 4, 5, 6, 7, 8. Okay? In nano, we have a 0 or 8 zeros before 1. After the decimal, in 1, 2, 3, 4, 5, 6, 7, 8, then 1. And our last, pico, is pronounced as pico, with a symbol of small letter p, and equivalence of 10 raised to negative 12 or equivalent to, let's count again, 0.00000000001. So we have how many zeros are there between decimal point and 1? So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in pico, we have 11 zeros between decimal point and 1. Okay, let's have a recap. We have two major ways of measuring things, and these are non-standard way of measuring and the standard unit of measuring. The non-standard way of measuring is measuring things with accordance of convenience rather than accuracy. Example of its measurements are the use of hand, span, foot, cubit, kernel corns, walking, etc. There are two standard systems of measurement, namely US customary system or English system and the metric system. The US customary system or English system is based on the British imperial system. Its units evolved from non-standard units of measure in medieval times. It does not use a base unit and prefixes. The units used under English systems are inch, foot, yard, mile, ounce, pound, ton, quart, pint, and gallon. The metric system is widely used standard system of measure. It's based on decimal just like our numeration and monetary systems. Introduced in 1970 by a Frenchman named Gabriel Mouton. The system is based on multiples of 10. Counting and performing mathematical operations are easier. The metric system uses Greek and Latin prefixes to make conversion from one unit to another in easier way. A prefix is a power of 10 exponent or multiplier that precedes the unit. The units under metric system are, under Greek, we have tera, giga, mega, kilo, hecto, and deca. In Latin, we have deci, centi, milli, micro, nano, and pico. Congrats! And we just finished discussing about measurement, non-standard way of measuring, and the standard unit of measure. I hope you learned and gained knowledge after watching this two-part video of this topic. See you all on another video. Bye guys!